PMC was founded by a professor of simulation technology at University of Michigan Dearborn in 1979 when his students included engineering professionals at Ford learning the new digital engineering technology. They recognized the value of and its impact on their lean initiatives. PMC was founded as a simulation consulting firm. Today, PMC still retains numerous PhD and master's degree holders to remain on the leading edge of new technology. PMC is still headquartered in Dearborn, Michigan, and has developed a nearshore, offshore delivery model to maintain the highest quality project management with lower cost of services. The primary goal of PMC is to establish a long-term relationship with their customers through superior customer service and a deep understanding of the customer's needs. 80% of PMC revenues are from repeat customers. Many consultants can provide single services. PMC is unique in its ability to address all digital engineering needs throughout the life cycle of an AEC project. Engagements can consist of training or mentoring, outsourcing of modeling and simulation, or software equipment selection based on your specific needs. These are the topics to be presented today: laser scanning and 3D modeling, lean and industrial engineering, and simulation and visualization. With scanning, it becomes more possible than ever to achieve design certainty. With design certainty, there are new opportunities for saving time and project costs. PMC has been utilizing scanning for 15 years and is well versed in the evolution of the technology, helping clients avoid the mistakes and pitfalls made with earlier versions. Today, terrestrial scanning is used in all phases of project development, whether it is fast and accurate feasibility studies or ongoing facility maintenance and operations. The challenge is identifying at what stage of the process scanning can yield the highest return for you. PMC can help. The traditional method of creating a true as-built of existing structures can be time-consuming and expensive. Rarely are accurate plans available, and most often field measurements have to be verified multiple times. Using digital laser scanning, the accurate data is captured one time and be converted directly into the CAD model. This is the typical workflow for terrestrial scanning. The basic process is to plan the scan, which is in the field time, register and process done in the office, and then a handoff to the design team. Using PMC's expertise in laser scanning and 3D modeling, we can deliver to our customers any format that is best for them, from the native point cloud data to a recap or Navisworks file, or even a complete 3D Revit model. In most cases, scanning is significantly less than traditional field checking. Our team can capture up to 100,000 square feet or more per day on site. Unlike traditional field checking, the scan data is accurate, more complete, and more suited to today's modern workflows. PMC has scanned over 150 million square feet. With today's technology, the scan data can be viewed in a variety of formats, including handheld devices in the field. Our first case study focuses on a project we completed on a building that was over 100 years old, with no existing as-built models were available, and field measurements weren't accurate. Errors found during the course of demolition prompted the general contractor to call in PMC. We completed a deviation report of the plans versus the actual as-built. This picture is the point cloud data from our exterior scans. One of the most striking finds was the floor deviation from level, one side of the building to the other. The results of the laser scan could provide an accurate map of where remediation was needed. Other valuable information was provided on condition of the brick walls, parapets, and the roof. It was possible to overlay the scan data directly on the CAD layout to visualize the variances and where corrections needed to be made. This saved countless hours of corrections to be made on the construction site and cost overruns. The next case study is the NASA Vibration Chamber. This is the largest vibration chamber in the world, designed to test reliability of rockets in liftoff and re-entry. This vibration chamber is used to test many different types and sizes of rockets. The rockets are placed on the table in the center of the chamber, and they are vibrated until they start to fall. Scaffolding is erected prior to the test to secure the rocket before it falls. As multiple rocket dimensions are used, scaffolding must be engineered to exact specifications. The point cloud data of the chamber can be combined with the CAD model of the rocket for precise accuracy. This is the color scan of the chamber. Our project included 3 hours of travel time and 4 hours to scan. From the point cloud data, a step model was produced in 48 hours of engineering. The complexity of the geometry of this facility would have made manual field measurement nearly impossible, and accuracy would have been an issue. If you are interested in more details on laser scanning, PMC has produced another webinar, 3 case studies in 30 minutes, that is available on YouTube. We will also be presenting an ROI analysis of laser scanning for architecture in August. PMC has been a leader and innovator in lean principles. Our expertise and success in the manufacturing sector directly translates into process improvements in virtually any commercial enterprise. With the introduction of BIM and 3D modeling, the AEC sector is now benefiting from these same technologies and principles. Architecture is being advanced from strictly the design of the building to how it will be used. Many architects are now using workflow analysis to provide the right spaces for the changes in how companies work today. Some examples would be more collaborative spaces, hoteling concepts, and minimizing storage area through just-in-time delivery. This also supports lead design. Don't build more than what's required. Using value engineering, the functionality of the project is often improved as well as producing tremendous savings, both in initial and lifecycle costs. Early reviews gives the assurance that all reasonable alternatives have been explored in a cost-effective manner. PMC can aid in the validation of a concept before design. In healthcare, for example, the concept of patient-centered care reduces wait times and increases overall patient satisfaction. In keeping with lean principles, the earlier that digital models can be utilized, the fewer changes have to be made past schematic design. Simulation can be a powerful tool for proof of concept and design validation, modeling people and processes and how the building will be used. Simulation technology is at the core of PMC's expertise. Discrete event simulation is the modeling of a closed loop or defined process, such as a specific workflow. As there are a myriad of projects, there are also specialized simulation tools for specific applications, such as industrial, medical, and office. PMC has the ability to choose the right tool for each project. In the interest of time, we cannot showcase our expertise in the wide range of industries that we have produced simulation studies for. Please go to our YouTube channel to view. Along with the visual animation of the simulation, graphical analysis can be available to optimize design functionality. This is valuable in identifying issues such as bottlenecks and optimal traffic patterns. This is a case study in simulation for the expansion and renovation of a medical facility. The architecture firm wanted the design based on patient-centered care. What was the optimal design for both patient care and staff workflow? PMC developed a simulation model that could explore the options before schematic design. The results show the architect and client the optimal design for allowing for better care for patients and a hard dollar ROI for the hospital in both cost per patient and increased utilization of resources. PMC works with an exciting new technology, pedestrian simulation. Where discrete event simulation models a specific process, pedestrian simulation can model crowds, including variables such as walking speeds, obstacles, and attractions. Today's emergency planning includes multiple scenarios: evacuation of the building, lockdown, hazmat, and explosions. This is a valuable tool in both design of a new facility's functionality and creating optimal operation plans during renovations. Pedestrian simulation can model crowds of up to 100,000 people. This can be used for design of large entertainment venues and also for planning of new events at a facility. For example, in an athletic stadium, if they want to use the arena for a concert event, approximately 20% of the stadium will be closed to the public for the stage and backstage areas. This will greatly alter existing emergency procedures. New evacuation procedures must be put in place. Additionally, the Department of Homeland Security has been citing venues for inadequate evacuation procedures. Simulation tools can help verify alternative plans before costly renovation designs are made. In addition to the animation, graphical analysis can be made to detail where unacceptable conditions arise. This map shows where bottlenecks and free flow of traffic occur. The simulation model can alter conditions to eliminate problems. For example, a venue may want to test kiosks versus manual booths. If there is an interest in attracting customers to a specific location, such as a retail booth or concession stand, alternative designs can be evaluated in the model. In closing, the advantage that PMC brings to their customers is in a number of areas. We can be a technology partner when advanced technology is required beyond the in-house capabilities, providing the best-of-breed solutions. We are vendor agnostic, meaning we will work with whatever technology is best for the client, and we offer flexible options, whatever is best for that particular project. Thank you.